Hello everyone, this is part 2 of the Consumer Choice series. Today I'll be talking about indifference curves. Before we start, a very important assumption is that a consumer is always rational. This means that a consumer will choose the best option for themselves, ceteris paribus. That is, considering everything else to be constant, a consumer chooses the option that's best for them. Now, what's the implication of this? A consumer being irrational means that a consumer will always have a well defined preference. This means that there will be bundles the consumer will either favor over the other, or the consumer will be indifferent between them. And these preferences, they're decided by the utility that the consumer gets from consumption. Now, utility is another important concept in consumer theory. It refers to the satisfaction that a consumer derives from consumption of a good or service. It is intrinsic in nature and allows us to assign a numerical value to the consumption done by a consumer. Now let's understand preferences and utility with an example. Let us assume that there's a consumer who is consuming two goods, apples and glasses of lemonade. Now they have a choice between two bundles. The first bundle is one with 4 apples and 3 glasses of lemonade, which we are assuming gives a utility of 5. The other bundle is one with 4 apples and 4 glasses of lemonade, which gives a utility of 6. Now the consumer will choose the latter bundle because it gives the consumer a higher level of utility. Thus, we can say that there is a well-defined preference of second bundle over the first. So from this, we have seen that bundles can be ranked. But is there a rule that a consumer has to follow to do so? Yes, there actually is. We say that preferences are monotonic in nature. What does that entail? It means that between two bundles, ceteris paribus, a consumer prefers a bundle which has either more of both the goods or more of at least one good without reducing the quantity of the other good. Now we can understand this with the help of an example. Let's assume that the consumer is being given a choice of 3 bundles. Bundle A with 3 pens and 3 balls. Bundle B with 3 pens and 4 balls. And bundle C with 4 pens and 4 balls. The consumer here will prefer consuming bundle B over bundle A and bundle C over bundle B. While talking about preferences, I had talked about the fact that a consumer can be indifferent between bundles. When will this happen? Given two bundles, if one bundle has more of good 1 but less of good 2 than the other bundle, then a consumer will be indifferent between them. Let a consumer consume two goods, good 1 and good 2, and let there be a choice between two bundles, the first bundle being x1, x2 and the second bundle being x1 plus delta x1, x2 plus delta x2. A consumer will be indifferent between these bundles if either of the two cases happen. The first case is if delta x1 is greater than 0 but delta x2 is less than 0. If delta x1 is greater than 0, it implies that good 1 in bundle 2 is more than good 1 in bundle 1. But delta x2 being less than 0 implies good 2 in bundle 2 is less than good 2 in bundle 1. The other case would be where delta x1 is less than 0 but delta x2 is greater than 0. Here, good 1 in bundle 2 would be less than good 1 in bundle 1, but good 2 in bundle 2 would be more than good 2 in bundle 1. Therefore, to remain indifferent between bundles, a consumer has to sacrifice quantity of one good to gain more units of another good. For example, let us suppose that we are consuming pens and balls, and there are two bundles A and B between which the consumer is indifferent. Let bundle A have 10 units of pens and 10 units of balls. Let bundle B have 9 units of pens and 11 units of ball. Thus, as the consumer moves from bundle A to B, they have to give up 1 unit of pen to gain 1 unit of ball. This is the rate of substitution, and this is diminishing in nature. That's because as consumer gives up more and more of one good to gain another good, the utility that he derives from each successive unit of the latter good, it keeps declining. For example, assume you start with 11 glasses of water and one packet of chips. A person comes to you and says, "Hey, I will trade as many packets of chips as you want for one glass of water." Initially, you gave up one glass of water for one packet of chips. You finish the packet of chips and you feel very happy. Thus, the satisfaction or the utility that you derive from eating that packet of chips is quite high. But as you keep on trading your glasses of water for more and more packets of chips, after a point you feel sick of eating more chips. Thus, you can say that the utility that you derive from each successive unit of a packet of chips that you consume, that keeps declining. This is what causes the declining rate of substitution, and this is what will help us determine the shape of the IC. Now that I have talked about preferences, utility, rate of substitution, it is time to talk about what indifference curves are. An indifference curve is a graphical representation of a group of bundles between which a consumer is indifferent. Because of diminishing rate of substitution, an IC would be convex and also downward sloping. Two ICs can never intersect. That is because higher ICs always have higher level of utility. Now you might wonder why that is. That is because at a higher point, a consumer gets at least more of one good, if not more of both the goods. Let us understand indifference curve with the help of a diagram. We are assuming that a consumer is consuming two goods, good X1 and good X2. Indifference curve A is a downward sloping curve and it's convex in nature. A consumer would be indifferent between any points on this curve. Let there be another curve that intersects indifference curve A called indifference curve B, and let Z be the point of intersection. Let XA be any point on indifference curve A and XB be any point on indifference curve B. Since point Z falls on both indifference curves A and B, it implies that it gives the consumer the same level of satisfaction as point XA and XB. Thus, by logic, the utility from both these points should also be the same. That is, utility from XA should be equal to utility from XB. Now, this cannot be possible. That's because XB is placed higher than XA on the indifference curve map. Thus, we have also proven graphically that two ICs cannot intersect. Lastly, we'll be looking at the slope of an indifference curve. A slope measures the rate of change. and mathematically slope is equal to change in y upon change in x. Let there be two bundles between which the consumer is indifferent, and we are assuming these two bundles are A x1 comma x2 and B x1 plus delta x1 comma x2 plus delta x2. From this we can see that change in good x1 is delta x1 and change in good x2 is equal to delta x2. The slope would be equal to delta x2 upon delta x1. To gain delta x2, consumer must give up delta x1. With this, I'll end the video, and if you have any questions, leave a comment. I'll try to answer. I hope I was able to help someone out with this video today. And bye bye. See you soon.